Good morning, everyone. Thank you for joining the second part of this Quarkus master course. Monday, it was Alex, your host. Today, I have the pleasure to do this second part of the course. I'm Sebastian Blanc, and I'm really happy to do this second part of Quarkus. And we will focus today more on the cloud native part. Okay? Please let me know in the chat if everything is okay, if the sound is correct. Let me do a scene change and see if I can, if you hear me well, if I change my scenes, because sometimes I have some glitches with the audio. Okay. Let me bring back the chat here in front of me, and then we can move on. Okay, can everyone hear me? I see that the stream is complaining about not enough video. Please let me know in the chat if everything is okay, please. And then we will start. Let me move to the slides. Okay, so let me continue. If something is not going well, if it's buffering or something like that, I will try to fix it. I hope it's okay. And okay, yes. Hey, Sebi, you can. Thank you. Because I'm worried I got a big warning on my streaming feedback. Okay. So I'm going to talk about Quarkus' second part. So just before we dive in, let me do a quick reminder about the coming schedule. So today we are doing the second part of Quarkus. So I'm doing the Asia time zone. I will do the French time zone as well. We will have a Portuguese session later this afternoon, an US version and a Spanish version. In 2 weeks, we will have our Kubernetes master courses. It's a 2-part course. So if you don't know anything about Kubernetes, that's a great opportunity for you to learn more about Kubernetes. And the week after, we will have a Kafka course and an Istio course. Okay, so be sure to attend these courses. As usual, I will share with you the slides. These are the slides, and this is a tutorial, and here are the slides. Okay. Oh, my stream is back to normal, so I'm reassured. For people that don't know me, I am Sebastian Blanc. I'm based in France, in the south of France. I work for Red Hat, of course, in the same team as Alex, Kamesh, and Burr. It's the developer experience team. And I'm really happy to give this course for you today. You can follow me on Twitter. You can see my handle, but also up there in the red, you can see all along my handle. So please follow me. Okay, let's go. So Monday, Alex showed you a lot of stuff. Let me do a quick recap of what we saw together. Let me bring maybe the tutorial here. So what we did last time was how to create a simple Quarkus app using the Maven plugin, how to expose a REST endpoint, and then we played with the Quarkus dev mode, launching your application in dev mode, changing the code live and see the live reload stuff. We saw how to do some configuration, so how we can inject a configuration property into our code, and how we can change that as well live. Then we went on the persistent layer. How can you add a persistent layer in Quarkus? And we showed you Hibernate with Panache. So that is Panache remove all the extra friction that you could have with JPA, like injecting an entity manager or stuff like that, writing easily queries for finders for your entities. Though we saw that, I think that Alex also showed you how to create a container image for your app and how to generate the Kubernetes resources for it, and even how to push it to a Kubernetes cluster. He probably also showed you some stuff around the Spring compatibility, because I guess here there are some Spring Boot developers. We also love Spring Boot, and Quarkus brings some libraries to add Spring compatibility. So if you're used to do Spring Web, so not used to do JAX-RS, but Spring Web, you can use the same annotation as Spring. Let me just bring here my code, for instance. Look, that is what I did Monday for the French version. I created simply a endpoint listening on Spring. Using here, you see REST controller, like you will do with a Spring Boot app, with the request mapping, and here a get mapping. And that is just working. Okay. By the way, I can maybe launch this app, Quarkus dev. Let me launch this app, and let me bring back the. And here we go. Okay, it's running. So here I had two endpoints, a JAX-RS endpoint. So for my fruits, you remember we did stuff with fruits. I can create fruits, retrieve fruits. We will continue today with fruits. Let me double check if that's still working. Here exactly, I can choose my fruits. I can filter on season. So give me only the summer fruits, give me only the spring fruits, okay. And I probably have also my spring endpoint here, spring hello spring. And just to show you the live reload stuff, hello spring, this is the second part of the course. Okay, let me save that, and here we see that we had the live reload. Okay, so today we will move a bit more around the cloud native functions. Once you decide your app is ready to go to the cloud, to a Kubernetes cluster, there are a few things that you must take care of. The first one is that you will probably have to communicate with other services. So that will be the first thing that we will learn today, is how to implement a REST client, meaning that my app can consume another service, another REST service, okay? Could be an external service, could be another service from your cluster, doesn't matter. And we will see together how easy it is to build this, okay? For this, first thing we need is an extension, okay? So adding an extension, you can do that using the Maven command line, but you can do that also directly from your IDE, from your VS Code. So if I bring up the palette here, and I can see here I have Quarkus, add extension to the current project, okay. And here let me search for REST client, okay. And this is the one that I want to use, REST client, okay. That easy, I add it, and it will be added to my project, okay. So now we need a service that we will consume. So I could build another simple service and consume this service, but instead we're going to consume an existing service which is available on the web. And let me share this service that we're going to use. And if we go here with client, we are going on the FruitVice service. FruitVice is a service where you can pass a fruit and it will give you some information about the fruit. I can probably do here API fruit banana. If I do that, it gives me some information about the banana. So which family it is, and really important for our case, nutrition values. So it will be nice that we enhance our current application that is a fruit CRUD app with this information. So what we will do every time that we retrieve our fruits from our database, for each fruit, we will also retrieve this extra information from this service. Okay, so let's see how we do that. Really, first thing that we will do is we will create another object that contains the information that comes back from this external service, okay, from FruitVice. So let's create a new class that we will call FruityVice.java, and that's a Java class, of course. And here we have some information. Just to make it easy, I'm going to copy paste because it's not really interesting. And again, you can find that in the tutorial. So let me just copy paste that. And here we go. Okay, so that should be good. We have a name and we have a nutrition value. Nutrition value is here a public static class that we define inside our FruityVice class. Okay, so that represents really what will come back from this external service. And now we need to define our REST client interface. In Quarkus, we base the REST client on the MicroProfile specification of a REST client, and it is based on creating an interface. So let's create the interface for our REST service. And we will call that my FruityVice service.java. Okay, it's a Java class. Exactly, and here I can start with some annotations. So the path, where do I need to consume my service? So it's on fruityvice.com, and then it was something like /API/fruit. Okay, and then we specify that. Oh yeah, by the way, I did an error here. It's not a class; it's an interface. No problem, okay. And here we added this second annotation, and here we say I register this interface as a REST client, okay. And now there's just one thing we need to do is define one method that will consume this service, okay. So it will be a get. Here we go. And it is go to the path / the name of the fruit, so that will be a parameter. Let me add the codes here, okay, and let me add annotation. It's still early for me, sorry, I need to wake up. And let me add a producer, because it will produce some JSON, okay. So JSON, and here we go, media type, no, not from Google, oh, come on, media type. Let me just remove the media type from Google. It should work, but just to be sure, media type from Jaxares. Okay, here we go, and I want some JSON. And I define here the signature of my method, and it will be returning a FruityVice object that we just defined before. It will return this, and I call that getFruit by name, for instance. And of course, I have a path parameter, this one, so I need to define it here. Path param, here we go. Path param that is called name, and which is the string name. Okay, so here we are. We are almost done. We need to do one extra thing. We need to tell the service, because it just have the path, but it don't have the base URL of our service. Okay, so there are two ways to do that. I can define that in the properties. So let me go to the properties here, and let me add a new property. And here I need to change the package org.sebi.fruityvice-service. I say MicroProfile Rust URL. It will be consuming my fruits from here. Okay? Let me just show you another way of doing that. And personally, I really like this way. Is you can, if you want, pass the base URL directly here from this annotation. So it's up to you to decide which is the easiest for you. Okay, there we go. Let me go. I see there's no comments. Okay, awesome. We can continue then. Next step, what I want to do, I need to merge. So we have now this fruityvice object. And we have this fruit object that we created Monday. And I need to merge more or less these two entities. And for this, I'm going to use a DTO pattern, data transfer object. Okay, so let me create a fruit DTO. And again, here I go here and I create a new fruit. And let me call this fruit DTO.java. Okay, there we go. It's a class this time. And again, let me copy paste from the tutorial because it's a lot of typing and it doesn't add a lot of value if I lose time typing this. So here, for DTO, we have a name, we have a season like our entity that we had here, but this time we also have some information about the nutrition, carbohydrates, and the number of calories. Okay, and then we have some nice constructors that will take or all the values, or it can take a fruit from our own entities and a fruityvice that we will retrieve from our service and create a fruit DTO. Okay, so we're progressing. So the last thing we need to do is inject our REST client into our fruit resource here in our JAXA REST endpoint in order to retrieve all the information from the external service. Okay, so really first thing we need to do is to inject our REST client. And to do that, I just can do a REST client. Here I get an annotation REST client. And here I specify that my REST client is the fruityvice service. Okay, fruityvice, and let me call it fruityvice service. Why did I? Okay, he's complaining that I should inject it, but that is not necessary. Okay, fruityvice service, here we go. And now I can call my fruityvice service. If I go here, fruityvice service dot, I can do get fruit by name, okay? But what we want to do is when we retrieve a list of fruits, for each fruit, we want to make a call to this external service, okay? And what we do here for now is that we return, we are returning a list that is returning, let me see, that is returning a list, okay? And one really nice thing with Hibernate Panache is that you can return directly a list of fruits, like we do here, but you can also return a stream. And that is exactly what we want. We want to be able to retrieve a stream so we can manipulate each item that is retrieved from our database. And this way we will be able to retrieve to call the fruit service for each item. Okay? Let me see. Let me just copy paste because I'm too scared to make errors, but I will walk you through the code. So, let me see. Oh yeah, and one thing we have to change. We're not returning now a fruit, but we are returning a fruit DTO. Okay? Fruit DTO from here. So that should be correct. Let me see. Find by season. So I'm just looking why he is complaining here. Cannot infer type for error map. Why is he complaining? Let me just copy this. Here, this one. We go to the fruits and list. Oh, okay. He's not happy. Let me just what is happening here? Food device service. I can see if it's if he is complaining. Maybe let me just go here to fruits. Yeah, he's complaining. Compilation failed, error, find symbol. Okay, he's just complaining. I probably did a typo here. No? Could that be this case that I did it? Oh yeah, I did a typo. Okay. Sorry, and I need to get the collectors. Okay, so let me explain quickly what we do here. So here I retrieve a stream of all my fruits that are in my database. You remember here, when we start the application, we inject all these values here. So here with Hibernate Panache, I retrieve all my fruits and then I do a map. Okay, I map my stream and here I say for each item, for each fruit, construct a fruit DTO with the fruit item that I have and the fruit vice object that I retrieve here using my REST client, okay? And then I have the default version if I'm not using my season query param, okay? So that's pretty clear how it works, and that's a really nice thing that you can expose a stream in your entity. And that should work now. So if we go back here and that we refresh, there we go. And there we are. So we get our fruits. For instance, I get my mango is from spring, and I add my carbohydrates values, my calories. I can probably retrieve also by season summer, and here I just want the summer values. So I have my banana, carbohydrates, and I probably have an error here with calories because it's always 0. Not sure why, but let me see. If we go to fruity vice, why I'm trying to do that now? Okay. Fruity vice. Oh yeah, here we go. Let me just double check because I don't understand why it's calories. Okay, so I have an error with calories. Maybe I did an error here with, let me see, double. It's a double calories. Okay, not sure what is happening here. But anyway, the most important thing to notice here is that I was able to retrieve all my fruits and then call my REST client and merge both results, okay? And you saw it's pretty easy to do. Let me check if there are some questions, and I see there are some questions here. Oh my gosh, DTOs are back. Yeah, I know. The good old times. I believe you misspelled the name of the service. Yeah. Oh, thank you. Fruits don't have calories. Yeah. I really wonder why the calories are not retrieved. Not sure what is happening here. Looks like my DTO is doing something weird. Okay. Anyway, that's it for REST services. And so basically, if we do a quick recap, what is important is to define this interface, okay? And define here which calls you will do with your REST client, and then define the path. And that is the important part, register REST client, and then you can see here it's just a matter of injecting your REST client. So I find it pretty nice. If you come from the Spring Boot world, you're probably used to REST template construction. I find it more or less the same here. Okay, let's move to the next part, which is fault tolerance. Okay, so one thing really important is when you will go to the cloud, so you will be able to call other services, but pods can die, clusters can die, nodes can die, service can be really slow. So you need to be resilient. You need to be able to deal with the fact that maybe your service that you're calling is not working. And what you really want to do is to have some fallback, okay? And again, Quarkus comes with some nice libraries based on the MicroProfile specifications called fault tolerance, and it's pretty easy to add fault tolerance to your project. So let's start by adding a new extension, and this extension is called fault tolerance. This one, okay. And now we are going to we will be able to add some annotation to deal with fault situations like network outage, or I don't know, whatever could happen. Okay, and what we're going to do is to annotate our REST client, because that's the one that could have an issue because we're not sure if FruityVice service is always running. Okay, and first thing we can do is, for instance, have a retry. So because maybe the service is still loading, is still starting, and you want to have some retries before you fail. Okay, so here I can max retries. For instance, is 3. I want maximum 3 retries, and between each retry you can wait 2 seconds. Okay, so let me add here the retry. There we go. No, cancel. Okay, I click on the link here, sorry. Okay, retry. Okay, so that is that easy to add a retry. So if I call my service here, compile failed, Java error. What did I do? Class retry. Why didn't fault tolerance does not exist? Did I save it? Let me double check the. Let me double check here that the fault tolerance is here. Why did he not accept my? Did I do a no fault tolerance retry? Let me add it again here. Okay. Not sure what is happening. Demo gods are playing with me a bit this morning, I have the feeling. Fruits, come on. Let me just stop the app. Let me build it again. Not sure what I'm doing wrong. Let me check in the chat. Maybe someone has found the error. If you find the error, what I did wrong, and it's probably me doing something wrong, just tell me, okay? Let me do it again. Okay. These are the kind of situation where have you tried to stop and start again works. Okay. Normally I don't have to stop my application in dev mode. For some reason, it didn't pick up my fault tolerance library, which is weird because it was available here. You could find the annotation. Okay, but it's working. Okay, but you didn't see anything special here because I don't have any delay. Okay, so I'm looking at how I can show you that, because I want to reproduce the timeout, and usually I do that by shutting down my network. I'm streaming on a different network, so I could do it here, but still risky. Let me try to, for instance, change the name here to something that doesn't exist. That should work, yeah. And we should have 3 retries from 2 seconds, so it should wait for 6 seconds before saying it cannot access my service. So let's see if it works. 1, 2, 3, 4, 5, 6, 7. Okay, it's a French counting, so it's 1 second more. And okay, here you say you cannot access my service. Okay, so but you could see that there was some delay because he did 3 retries. But that doesn't really help. Here we can do retries, but we are not resilient. We want to be able to handle this error, okay? We want a fallback. So let's see how we can add a fallback to this. Let me go back to my code here, and what we're going to do here is to add some fault tolerance by providing a fallback class. Okay, so here I have an annotation called fallback. Okay, and the fallback is the one, let me see, is this one, fallback. And here I can provide 2 stuff. You can provide a fallback method. So you can specify, if my service is not responding, fall back to this method, and this method can return a string saying sorry, service not available. But you can also fall back to a fallback class, and that is what we're going to do right now. So let me put here, for instance, we do a fruit rice callback dot class, and of course this class doesn't exist. So let me add this class. Let me copy paste it from here. Here we go. Fallback handler. Fallback handler. That is the one. Okay. Execution context. Let me just pick the fallback execution context. Is the one from MicroProfile. Okay. And that is okay. So here I say if my methods fails, go to this class, and this will return an empty fruit. Okay, from nutrition. So okay, so there we go. And let's try it again. So you know what? Let's remove the retry, because otherwise we need to wait for 7 seconds. And we still have our faulty service, so it should fill immediately. Here we go. Ooh. Here it's working. That is scary. Did I get back here to my service? No. That is awesome. It should fill, but actually it's looks like there are some. Oh no, it's working. Sorry, it's working. So yeah, it is working. I was confused. So it still can retrieve the fruits from my database, but it cannot retrieve the values from the fruit service. And what we said here is to default to an empty fruit with 0 values. Okay, so my service is still working, and I fall back to my fallback class that sets just these values to 0. Okay, so that is fault tolerance. And to be honest, the fallback class approach is, I show you that because that is what we have in our tutorial, and that is what my teammates decided to show. Personally, I prefer the fallback method approach. It's much more clearer. You don't have to define another class with implementing all this stuff. You just provide a method, and it's I feel it's more Quarkus way of doing things. Okay, but this is just my personal opinion. Let me check the chat. Here we go. Foods don't have calories. Awesome. Okay. And we can move to the next part. If you have questions, please don't hesitate, because this is an interactive session, and one advantage is that we have a chat and we're live. I know there's some delay. There's 20 seconds or 30 seconds delay, but yeah, don't hesitate to come over and ask questions. Okay, next part that we're going to see together is, let me bring back the tutorial here, is the health check. So now, still imagine we are pushing our Quarkus app to a Kubernetes cluster. Now we are able to call other services with the REST client. We can be resilient, so we can resist to failures of other services. And another really important thing when you deploy an application, not only Quarkus, but a Spring Boot app, a Node.js app, into a Kubernetes clusters, are the health check, the health probe. Kubernetes is really smart. The scheduler is really smart, really powerful, but it needs some help. It needs to know when your application is ready to serve request, and it also needs to know if your application is still alive or not. And so you need to help the Kubernetes cluster by providing this information, and that are called the health probes. Okay? If you add that, the deployment of your application will be way more efficient. So that is a really important thing to remember, is to add health probe to your application. Luckily, with Quarkus, is pretty easy to add. You have an extension that will provide these endpoints for you. Okay? And well, let's do that together with our current app. So again, we add an extension. So I go here. Oh, let me clean up my code here. I don't need this import anymore. Okay. And let me open the palette here, add extension. And let me add something. If I look for health, I got small y health. That is way too hard for me, for a Frenchman, to pronounce. Again, it's based on MicroProfile specification. So you can see here in the session that a lot of extensions are based on MicroProfile, because MicroProfile was, by essence, designed around cloud native applications. So all this stuff, fault tolerance, REST client, health, you will see metrics. MicroProfile has been working on these specifications. And there's one implementation here from SmallRye, and that is the implementation that Quarkus decided to use and to Quarkusify. Okay, okay. Let me do that. I got now my extension, and if I don't do anything, let me go back to my app, and I go to health. You can see, for free, I get some endpoints exposed already. Okay, here it say my application is up, and here it mocks a connection to the database to see if everything goes fine. Okay, and that is fine. That Kubernetes can already use this endpoint, because if you get a response from this endpoint, you consider that your application is ready to serve some resources. Okay, and before we go on, let me show you that. Monday, you remember with Alex, you added the Kubernetes extension to generate the Kubernetes resource files. Okay, let's go here to my application. Let me stop it for a moment, and let me do an mvn clean package. Okay, and that should generate again my my tests are probably going to fail or not. I'm not sure. Oh no, I fixed my test. Okay, awesome. You remember that if you add the Kubernetes extension and that you build your jar, in the target you have a folder called Kubernetes with your YAML file that you can just apply to your cluster. Well, let me close this. Okay, you get a service, you get a deployment. And let's check this deployment. And let's check this part here. Because we added the health extension, Quarkus detected this. Well, my Kubernetes extension detected that we have the health extension as well. And you say, okay, so let me add the liveness probes to your resource file. Okay, so you get it for free. Now let's see how you can, and let me rerun the app. Let me do a clear here, MVN Quarkus dev. Here we go. Okay, so here we didn't define any custom health check, but of course you can define your own health checks, and that is what we are going to do quickly now. Let me copy paste because otherwise we will be short in time. So let me create a liveness probe.java. Okay, and here let me copy paste this. Okay, let me remove the package, and let's see together how to provide your own liveness probe. It's really easy. Two things to do. First one, you need to add the liveness annotation to your class, and you need to implement the health check. And the health check, you just have one method to provide, is called call, and I'm alive. And here we can change I'm alive, live from live stream. Okay. Let's also add a readiness probe. Remember, we have liveness. Liveness is used by Kubernetes to see if our application is still alive. And we have readiness. That is when we deploy our app, that our new pod is created. Maybe there's some startup time. We need to make some connection. We need to wait that one file is ready. That is the readiness probe, okay? So let's add a readiness probe. Let me go here and let me create another file called ready. I always type it wrong. Readiness probe. Okay, .java. And again, let me copy paste this. Whoa. Let me copy paste this again. Whoop. Let me remove the package. And again, similar to the liveness probe, here this time I have an annotation called readiness. Again, I implement the health check, and here I create a response. So health check response builder with data. So what you will do here in a real life situation, you will really call your database, do a simple select of our fruits, for instance, and if it's okay, we can return some data here. Again, we provide here some fake data. Okay, that's it. And now, if I go back to my app here, I go back to health. Now you can see my liveness probe here. I'm alive, live from live stream, and the database readiness check. Okay, and you can even fine tune this to have only the live one. So if I go here to live, I got only the live one, and if I go to ready, I believe it's ready, I got only the ready. Okay, and again, let me see. Let me build the app again, because in the previous version here you saw that I had only the liveness, and now that I have provided a readiness, I should have a readiness. Let me double check that. I was surprised to not see a readiness probe here. Here we go. Okay, and let me go to target, Kubernetes YAML, and I got only my liveness. I don't have my readiness. Okay. Oh no, readiness probe. There it is. Sorry. I had to look lower in the resource file. Okay, so here I have my readiness probe. So again, now what we did this morning until now, we added some fault tolerance stuff and some liveness stuff. So now if I deploy this app to my cluster, and we won't do that because it takes some time, but we can be pretty confident it will be resilient and will be only serving requests when it's ready. And because it's Quarkus, it will be really fast. But if something happens, if my pod is not healthy or something like that, the liveness probe will return a good answer, and Kubernetes will make sure to stop my pod and start a new fresh pod. Okay? So again, these are important things to know. Other important things to know when you are in a public cloud and you're not sure where your pods are running is to have some metrics. It could be that your one of your node is at the other side of the world and you want to measure how much time it takes to get a response from your endpoint, to count how many times one method is called, stuff like that. Again, for metrics, we got an extension, and let me add it right now. If we check for metrics, oh, sorry, I need to do first. Let me do that again. Add extension, and this one is called metrics. Again, from MicroProfile, from Smallwell implementation, metrics. There we go. And let me check the chat. No questions in the chat. Awesome. Okay. Let me drink some water. And let me add some metrics now. Okay. So what we will do is I will create a new resource here, a new endpoint, and that we will call time resource, for instance. Time resource, there we go. It's a class, yes. And what we will do here is we will it will listen on the pass time. Okay, let me check. Okay, and we have, let's say, a really simple method that return the current time. So it return an instant from Java time, and we call it now. Okay, and what it does, it just returns instant now. Okay, pretty simple method that just return the current time. Okay, we want this to be a get. Okay, let me see. We can double. Oh yeah, let me start the app again because I stopped it. Quarkus dev. There we go. What did I do? Here we go. Hop. Quarkus dev. There we go. So we should have this method now available. It should be fast to start. Okay. And if I go here to time. Oh yeah. I forgot to add a producer. It's really important that you always specify what your endpoint returns. In this case, it's media type, and it's just text plain, I guess. Yeah, text plain. Okay, there we go. There we go, time, and it gives me the time. Okay, again, you see the power of having this live reload stuff. That makes it so easier when you make errors, and I make a lot of errors. Okay, so let's add some metrics to that. For instance, we want to know how many times I hit this endpoint. What I can do with the metrics extension, I can add something called counted. Okay, and I can give it a time dot now. and I can give it a description. Okay, didn't. Here we go. Description. How many times? Okay. Here we go. And let me add another method here. Let me just copy that, because otherwise we will be late. Okay, and I got another one here where I want a Doge. I don't know exactly how you pronounce that. A Doge. Oh, come on. Why did he? Let me just add the import. Time zone. Here we go. A calendar from Java util. There we go. Okay, and there I want the offset from UTC. You remember when you register for this master course, it was in UTC, and here we can measure some time around this. Okay. Now, what we can do if we go here and we call time. Wow. Cannot. Are containing. What did I do again? Demo gods are already having fun with me. What did I do? Looks correct to me. Not sure. Usually, maybe it's because I run this app here from the terminal and not from my other terminal. I'm not sure. Here we go. Okay. So let me call it several times. Okay. And now I can check some metrics. Now if I go to metrics/application, here I get metrics that are formatted for Prometheus. So if you are deploying to OpenShift, for instance, and there you have a Prometheus available, it will be able to consume these metrics. You can send to Prometheus this endpoint, and it will be able to call to consume this metrics. And here you can see that I consumed 31 times the time method. So if I do that again, did I type this many times on it? I'm surprised. Let's go. 44 times. Okay. So it's that easy to add metrics to your application. Okay. I got 8 minutes left, and I want to spend this 8 minutes on reactive, because one important thing with let me bring the slides quickly here. Let me show you this slide. One thing what you can do with Quarkus is that you can mix in your code the imperative style. That is what we have been doing until now, but also the reactive style. And reactive style is really important if you want your app to be able to be scalable, be able to consume a lot of info real time or not. And the reactive is a good way to do that. And you can do that with Quarkus. And what I'm going to show you is a new extension called Mutiny, which is a new abstraction layer around reactive, which make reactive more easy to approach. Because let's be honest, even for me, reactive, when you never done reactive before, can be pretty hard to understand. Okay, so I'm not sure how far we will come, but let's try it. And first thing we are going to do is to add the Mutiny extension that will add all these reactive features to my application. Okay, so here I go for add an extension, and I look for a Mutiny. So write reactive application with the modern reactive programming library Mutiny. Okay, there we go. Awesome. And now it has been added. Here I see an error. Oh, I think I got the issue here. Okay, anyway, we will see that later. You know what? Let me just do something really quickly. let me set the correct Java. I think adding my extension is not working because it's using a different terminal where I forgot to set my correct Maven path. Okay, so that should be good now. Just for the safety, let me start this again. Okay, what we're going to do, we're going to consume again an external service that retrieves beers. But there are several pages of these beers, and so you cannot consume it in one time. And what we will do, we will create a reactive service that will iterate around all the pages of this beer service and retrieve only the best beers and mix that into one result and return that to me. Okay? Time for some hardcore coding. So let me create here a new class that we call beer.java. Okay, there we go. And let me copy this class here. So we have a simple beer class as a name, a tagline, and an ABV. So that's the score, and this we will be filtering the beers on this. Okay. Then we need a beer service, so a REST client like we did for fruits, but for beers, okay? And for this, we're going to create a beer service .java, and that will be an interface. And again, let me copy paste because I'm short in time, but I will explain quickly what happens here. So here I consume the version 2 of the beer API that is running on a service called, oh well, you know what? I can do it from here. Let me specify the base URI here, and it's we're consuming something from api.punkapi.com. That is a service where we can retrieve some beers, okay? And we want some beers, and there's a query parent, the pages, because I told you by default you get the first page, and if you want the second page, you have to query for the second page, okay? That's it. Let's create the beer resource. There we go. Let's create the beer resource. Beer resource.java. Okay, and let me copy paste this, because otherwise we will never have time. Doc or .sebi. Okay, there we go. So we inject our REST client, our beer service, and here we oh, I clicked. Okay, sorry, I clicked too fast. I click. Here I retrieve my beers and I create a multi. So I have 2 minutes to explain you Reactive, but again, we will have time to repeat that in the tutorial. But the important thing is that here in my Reactive method here, I am able to retrieve all the beers from this external service. And for each beer, I do a filtering by getting only beers that has a score higher than 15, and I bring that together in one list, and I return that finally here. Okay, and for some reasons I see it's not working. Not sure why. Let me see. Endpoint beer. Okay, I probably forgot something. Punk API, HTTPS. Let me just find where I could have done the error. Base URL. Okay, maybe I don't know what I did. Or the service is down there. Could be as well that the service is down. Let me go here to my properties. Okay, here we go, and let me change this part here, org.sebi. Okay, let me see if the service is working. Open, open. Yeah, service looks be up, so I'm not sure what is happening. Okay, here so demo gods were really. Come on, beer service. What is happening with me? I'm so sorry. That should have worked. He could not inject my service for some reasons. I don't know why, to be honest. If I stop it and I do it again, let me check here. Did I did anything wrong? Beer service here. Oh, maybe because of this. Okay, and there we go. Okay. I probably did something really stupid. I don't know why. I'm running out of time. But again, if you follow the tutorial and you are not in stress like me and you follow all the steps and you have the repo, you should be able to follow all this and have the service working. Then you have a second part, and for sure I have no time, but it's really nice to do here as well, is how you can use this mutiny and all this reactive stuff with Kafka. And we have a really nice example here that is not around beers, but around wines. And again, I let you the time. That is homework for you to play with this at home, okay? Security. Again, you can play a bit about security, but here I do a shameless plug. This Friday on the Dev Nation channel, this YouTube channel, but you still have to register, I will do a tech talk about Quarkus and security, and mainly articulated around Keycloud. I will show you how to add identity management to your Quarkus application, which is also really important. So if you want to learn how to do that, Friday, be sure to register to be at this tech talk. That's all for me. Thank you again for being there. There were some people, so let me double check the chat and remove. Oh, maybe someone has found an error. To remove developers. Oh, okay. So I did some error. Can I share the slides? Yeah, sure, Konstantinos. The slides are, I provided the link there. Let me put it again. QMaster. This is the tutorial. Here we go. And I'm just curious because someone told me remove developers. Oh yeah, there you go. Thank you. So just for the fun, let's see if it's working. Let me go to my beer resource. Okay, let me double check. Yeah, but it doesn't retrieve any beers. My app is working, but it doesn't retrieve any beers. I have to find this out why it's not working before my second session this afternoon. Anyway, thank you a lot. Sorry for the last part that failed, but it happens. We are all human. I really appreciate the time you took to attend my course, and I wish you an awesome day, and I see you next time. Bye bye.